Let me start with the easiest problem which was asked in CMI 2024 paper. And this time I just remind you the concept and the formula, that factor and remainder theorem. This question was of 1 mark, but good for starting. Consider this polynomial, and I am discussing just one part of the question because other parts I will be discussing when roots of polynomial done. For this polynomial, when divided by x plus 1, find the remainder. That factor theorem for two polynomials ax and bx, we can write ax equal to bx, and this is quotient, this is remainder. And when px is divided by x minus alpha, the remainder is given by p alpha. But if p alpha equal to 0, then x minus alpha going to be the factor of the polynomial. Isn't it? Ax is a given polynomial. You are dividing by bx. I write again. Ax is the given polynomial. Bx, the polynomial you used to divide ax by bx. Then qx stands for the quotient. And Rx is the remainder. Then Ax equal to Qx into Bx plus Rx. When you divide by x plus 1, the remainder will be what? X plus 1 you will write in the form x minus 1. So alpha going to be minus 1. So it is very easy to calculate p minus 1, just replace x by minus 1 everywhere. Minus 1 to the power 6, 10 minus 1 to the power 5, okay, 11 minus 1 to the power 4, minus 1 here, minus 1 here, minus 1 here, just minus 11. So the remainder going to be equal to 4. Now in this context I have explained how to calculate remainder when divided by a polynomial like 3x plus 2 or 5x minus 1. For finding remainder, you take 3 common here, 3 into x plus 2 by 3. The remainder will be, what is alpha over there then? X minus 2/3, p minus 2/3 going to be the remainder. And when you divide by 5x minus 1, how to calculate the remainder? You might have done before, I am just reminding you here. The remainder going to be p 1 by 5. Okay? So, this CMI problem, at least one part, was not difficult for you. Now let us go for a problem like this. Show that x square minus x plus 1 divides x to the power 20 plus x to the power 10 plus 1. I would like to remind you the roots of this equation. For x square plus 1 equal to 0, roots are minus I and plus I, where I is root minus 1. And parts of I are what? I square will be minus 1, I cube will be I square into I minus I to the power 4 will be what? I square this is equal to 1. So this I is called imaginary number. We will be doing more the application of imaginary number when we find the roots of an equation. And for x square plus x plus 1 equal to 0, the roots are by quadratic equation formula minus 1 plus minus I root 3 by 2. If one of the complex root is taken as omega, that is minus 1 plus I root 3 by 2, the other root going to be minus 1 minus I root 3 by 2. If you have not done all these things, then I will share one link of my video on complex number with you. There you will find detailed calculation on omega and I. Sum of 1 omega and omega square, this property also valid will be 0, and if you multiply these two, omega cube, that will be equal to 1. Now, how will I prove x square minus x plus 1 divides this one? You can't go by long division. We have done factor theorem, remainder theorem, not because of long division. But we will use the trick that when x square minus x plus 1, these quadratic polynomials factors are known, then if this one divides this polynomial, then x plus omega and x plus omega square are two factors of it. By factor theorem. So if px is the polynomial, we'll just check alpha is what? In this case minus omega. We'll just find p of minus omega. P of minus omega, you calculate omega to the power 20, omega to the power 10 plus 1. 20 is omega cube to the power 6 into omega square. This is omega cube to the power 3. Then omega to the power 9 into omega plus 1. But omega cube we have seen 1. You just put 1 over there. Then it changes to omega square plus omega plus 1, which is definitely equal to 0. So what have we got? This will ensure that x plus omega is a factor of this thing. Clear? Now second factor, x plus omega square, where alpha going to be minus omega square. If you replace x by minus omega square, then it is minus omega square to the power 20 plus minus omega square to the power 10 plus 1. Simplify it, it will be omega to the power 40, omega to the power 20 plus 1. Simplify it, omega cube to the power 13 into omega, that is omega to the power 40, omega cube to the power 6, that is 1 again, omega square, and again omega plus omega square plus 1 equal to 0. So this will ensure that x plus omega square is a factor. Now product of these two factors, x plus omega and x plus omega square, is x square minus x plus 1. So we can say that this will divide, x square minus x plus 1 will divide x to the power 20 plus x to the power 10 plus 1. So first example was application of remainder theorem, and this is the factor theorem. As you are going to deal with problems asked in past year's papers, so I have introduced, I have revised the concept of I and omega with you, and these kind of things are frequently asked in exam of past year's question papers, ISI, CMI CMI and other exams. Okay. Now let us go for next problem. Factor theorem, remainder theorem. I hope you have revised the concept. Let us go for the next problem now. The next problem going to be on this, that when you are dividing by a quadratic polynomial, what will be the remainder? This kind of problem you might have practiced for your IOQM or other examinations, but normal school level you haven't done. Then how to divide this polynomial by x square plus 1? We have avoided already the long division, so we will take the help of remainder theorem, factor theorem. But here this is not going to be a factor of this, because x square plus 1 today also I have done it with you. It is two factors, x plus I and x minus I. Okay. So if you put x equal to minus I over there, will it be 0? You can check once. There are 5 terms, pairwise they never get cancelled. And for x equal to I, no, 5 terms are there. So it cannot be equal to 0 when you divide this 10th degree polynomial by this quadratic one. Now another thing I would like to remind you, when you have used that division algorithm for polynomial, the remainder's degree always has to be less than the degree of bx. We don't know whether it will be 0 or not, but not 0 in this case, that I have told you. So Rx will be what? So what do you suggest for Rx? You think yourself. Rx will be what? Now Rx will be first degree polynomial. Already told, a first degree polynomial is of this form, ax plus b. So it will be justified to take Rx in the form ax plus b. Okay. So write in this form here, because we are going to find the remainder. They haven't asked for the quotient. We are not interested to find qx over there, Rx. And whenever you are going to divide, you will take the advantage of this factorization. You will be putting these values only over there, x equal to minus I or x equal to I or both. I have to get A and B, no? Then only remainder can be found out. So let us put x equal to I over there. Then remainder will be what? This part will be 0, a into I plus b here, and x equal to I if you put here, I to the power 10, I to the power 7, 4, I cube 1 equal to this. Simplify it, it is I square to the power 5, minus 1 to the power 5, which is minus 1, I square cube, that is again minus 1, odd power, I to the power 4 is 1, I cube is minus I, 1 ai plus b. See, once you put I over there, then you can get both a and b on comparison. This is the advantage of complex number. The number doesn't exist in number system, but this imaginary number helps a lot to solve many sums, I'll tell you, in many subjects. Okay, that I'll discuss later. Now here, if you put x equal to I, left hand side has become minus I and ai plus b, right side. Now go for comparison. Minus I means 0 plus minus 1 into I. This is B plus AI. AI. There is A over there. Okay. Now if you compare, what is the value of A and B? Coefficient of I here minus 1. This is A. So A will be minus 1 and B will be equal to 0. Okay. So A minus 1 and B 0 means the remainder Rx equal to Ax plus B going to be what? This is going to be minus x plus 0, that is minus x. So the remainder is minus x. Let us go for this one. So that x square plus x plus 1 divides this polynomial. Again, you factorize the polynomial which you are going to divide this polynomial of 16th degree. If this one divides this one, then the factors of x square plus x plus 1 will divide this one. X square plus x plus 1 is x minus omega, x minus omega square. So put x equal to omega over there. Where? In this polynomial. If we put x equal to omega there, then this is going to be omega plus 1 to the power 16, omega to the power 16 plus 1. This property I have reminded you today also. 1 plus omega square 0. So omega plus 1 is minus omega square. Put minus omega square over there. So this will be changed to omega to the power 32. This one omega to the power 15. Okay, into omega plus 1. And here this one 32 means you can write omega cube into 10 omega square. This is omega plus 1. So omega square omega plus 1 0. Therefore x minus omega is a factor. Okay, not a difficult one. Similarly, you put x equal to omega square over there. Remembering the fact that 1 plus omega square 0, we can do one thing from here, that 1 plus omega square can be replaced by minus omega. Put it there. So this will be minus omega to the power 16 plus omega to the power 32 plus 1. 16 is 15 into omega. Advantage omega cube 1. We put it there. This is also becoming omega plus omega square plus 1. This is a factor. So once you got x minus omega factor, here you got x minus omega square is also a factor. So their product which we got by factorization, that is x square plus x plus 1 is a factor of this polynomial. It means this one will completely divide this thing. Clear? Hope you have understood. This is another problem of the same type, but I am doing this kind of sums for my classes here because understanding is very important. To solve difficult sums, these concepts are very important. That's why even if you have done once, you need to revise. When you are dividing 10th degree polynomial by this one, this is what? A 4th degree polynomial, you have to find the remainder. This is just another example in the series. You write the given polynomial in the form x square plus 1, x square plus x plus 1, qx plus rx. Now degree of Rx is less than 4. isn't it? Why? Because Rx should have degree which is less than the degree of the polynomial which you are going to use for division purpose. So degree of Rx should be less than degree of this 4th degree polynomial, less than 4. So when we start a problem, we will assume that degree be equal to 3, maybe 2, maybe 1, okay? But we will start this manner, and polynomial of 3rd degree is of this form: ax cube bx square cx plus d. So x to the power 10 plus 1 going to be x square plus x plus 1, this into qx. Rx is what? Ax cube bx square cx plus d. Now we have done two sums. One is factorization of this concept, one was factorization of this concept. Here is combination of these two. But in our mind, we will keep that x square plus 1 has factors minus I and I, and this one has factors omega square. So to get the values of A, B, C, D, you first put x equal to minus 1 on two sides. Why? There is the advantage. There is the advantage of this thing, because when you divide this part, I mean when you put x equal to I on both sides, this part will be vanishing, because this one has a factor x minus I. So by putting x equal to I to the power 10 is what? I square to the power 5. I square is minus 1, you know. Minus 1 to the power 5 is minus 1 plus 1. Okay? And this part 0. AI cube bi square ci plus d. So 0 equal to, you put I square equal to minus 1, so minus ai minus b ci plus d. Now the advantage of complex number I told you. Once again it is proved the advantage. You just write d minus b and c minus ai on one side and 0 on the other side. Then go for comparison. D minus b will be 0, c minus is 0. This gives b equal to d and a equal to c. Okay? Now minus I if you put, there will be no change, because minus I to the power 10 will give you this thing. So I did not take the trouble of putting minus I am putting omega over there. For x equal to omega, it's coming omega to the power 10 plus 1. This part 0 I told you, because x minus omega is a factor of this, isn't it? That into qx plus a omega cube b omega square c omega plus d. Now omega to the power 10 is what? Omega cube into omega. That is omega only. So omega plus 1, omega cube 1 again, b omega square c omega plus d. We will remember this thing that we have proved b equal to d and a equal to c. So just substitute there, b equal to d and a equal to c. If you put it, then take the terms containing a together, terms containing b together. This is the game of omega. 1 plus omega square is what? Minus omega square. This step if you write, this is going to be what? A into minus omega square b into minus omega. Make all negative signs into positive ones. Then cancel omega from two sides. We have omega equal to A omega plus B. Take it on the left side, omega into 1 minus A equal to B. 1 minus A, omega you take minus 1 plus I root 3 by 2 equal to B. Then go for comparison. You write A minus 1 by 2 plus root 3 by 2 1 minus A into I equal to 1 into B plus 0 into I. Isn't it? Now go for comparison. This real part will be equal to this one. And this real part will be equal to this one. I mean 0. So it will give us A minus 1 by 2 1 and 1 minus A equal to 0. 1 minus A into root 3. It means A1 and if you put A equal to 1 here, it's going to be B equal to 0. Now A equal to C. So if A1, C must be equal to 1. If B is 0, D must be 0. So that remainder is a 4th degree polynomial which is ax cube, I just tell you, ax cube bx square cx plus d. A value is 1 you put, b 0, c 1, d 0, so it is x cube plus x. Alright. So I think you will not face any problem if this kind of questions arise in future. The use of omega square, I, minus I helps in many topics. This is one of the applications. Now see the question CMI 2020. The polynomial given this manner, 400 degree polynomial. 10x to the power 400, ax to the power 399, bx to the power 398 plus 3x plus 5, where a, b are real constants, is given to be divisible by x square minus 1. Now, this one attracted me a lot, that if you can find the values of a and b, write your answers as a, b. If not possible to decide, state so. As much as it was possible for me to collect, I have done it. Let us solve the main problem. We have to find a and b when x square minus 1 fully divide this one. I mean, no remainder is there. Okay? So we can write px equal to the quotient. We don't know what is the quotient. Dividing by x square minus 1, remainder is 0. Now divisible by x square minus 1, factors of x square minus 1 are plus 1 and minus 1. Put x equal to 1, you get this condition on both sides. This part definitely 0. Here it will be 10 plus a plus b, 3 plus 15, 0. And minus 1, 10 minus a plus b minus 3 plus 15 equal to 0. Now take a look at these two equations you got here. This one and this one. Are they similar? Are they identical? No. Because coefficient of a there, b there is equal to coefficient of b here. But age coefficient is not matching. So these two are not identical. Infinitely many solutions you won't get by the concept of that matrices determinant whatever you are doing, or even by using class 9-10 concept. So a and b definite values we can determine. I mean that only one solution is possible, probably. How? Let me simplify the first one. a plus b plus 20 is 0. Second one, minus a plus b plus 22 is 0. You add, getting the value of b. 2b plus 50 is 0. So b is minus 25. You put b minus 25, then a is coming minus 3. So a is minus 3 and b is minus 25. Hope you have understood. This is minus 3 minus 25. This was not a difficult sum at all. This question I have chosen to solve it in the class because I thought that can be done by everyone. CMI 2021 question. Consider polynomials of the form where a, b, c are integers. This is a polynomial of third degree. Name the three roots of fx to be p, q, r. And this may be typing difficulty from my side. This is not fi, this is f1. So fx equal to x minus 1 into this given plus 2021, where a and t must be integer. This option may be correct. And with p equal to 2, c 2021 may be correct. There is such a polynomial fx with r equal to 0.5 may be correct. The value of this does not depend on the value of c. I have chosen this sum. I had nothing to do without completing the sum. I could not leave the sum, the fourth part also. I will be telling you, following sessions we will be solving many sums based on symmetric function in case of equations. This little bit adjustment you have to do in today's class. When I have discussed D, it is not only the concept of factor theorem and remainder theorem, roots of polynomial required, on which our next session going to be. Okay, let me start. This is given, this polynomial x cube ax square bx plus c, where abc are integers, and roots they asked you to take pq all are linked here. If f1 this, can we take this thing? Let us verify it here. f1 2021, then can I take the point? This is 1. I am telling you repeatedly, this is 1, not I. It is possible. Why? Because fx is this. If you put x equal to 1, we are getting f1 2021 only. They asked you to check. If f1 this, then fx this. Yes, because first thing, this is a cubic polynomial. Coefficient 1, here also coefficient remain 1. The factor they have given, here we know that factor going to be. So first option is definitely correct. Can I go with this option also? C equal to 2021 and P equal to 2. C equal to 2021, they are not changing. P equal to 2 means that root f2 must be 0. Now put x equal to 2 over there. It is coming 8a, 4b, 4b, just a minute, I did a mistake over there, no one pointed out. 8a, not 8a, just 8, then this is 4a and this is 2b plus 2021 0. Now LH is going to be an odd integer total, because 8 is even, 4a even, 2b is even, 2021 only odd. And LH is odd, LH is 0 also, isn't it? Whole thing 0. Can I see that even integer and sum of odd integer equal to 0. Can it happen forcefully? Even if I have got it there by using the information that for p equal to 2 this is 0, this is not valid. Sum of even and odd integers can never be equal to 0 if by any chance you get this value minus 2021. It's quite impossible. So this option is not correct. There is such a polynomial fx with r equal to 0.5. Now put r equal to 0.5 over there. By putting x equal to 0.5, it is coming 1 by 8, a by 4, b by 2 plus c. See, again you are getting the same thing. Left hand side 0, and where even number, odd number involved, their sum you are telling 0, not possible. And 2a plus 4b plus 2c can never give you minus 1 like previous one. You can never get it minus 2021, here you can never get minus 1. So this option also incorrect. Why I told you this sum is wrong student, that is because of part D. But try to adjust with me, I will help you. This cubic polynomial, if it has 3 roots, P, Q and R, some of the roots, as you are studying advanced, you must have learned it. So some of the roots will be minus a. Some of the product of the roots, right now if you are not able to accept cubic equation, okay, do it like quadratic only. Sum is equal to negative of this coefficient. Sum of the products taken 2 at a time, that will be equal to b, and PQR, their product is going to be equal to minus c. So now check whether this is valid or not. It does not depend on the value of c, it is stated. So p square q square plus r square you calculate. It is becoming p plus q plus r whole square minus 2 into this thing. Put the value of p plus q plus r, minus a whole square minus 2b. A square minus 2b, no c is found over there. So this option is correct. This is CMI 2021 question. Day by day question may be difficult, but concept will never be difficult. If you have good concept on factor theorem, remainder theorem, division polynomial, I mean when dividing a polynomial by another one, the remainder, all these things, then you can solve these kind of sums easily.